what I ran into here a few weeks ago is I had one of these KPC3s, which is about a $200 device, but a really handy little device, pretty much bulletproof, that I had lent to somebody, and he sent it back to me and saying it doesn't work anymore. It was kind of flaky for a while, and you had to switch the power on and off to get it to work, and then at some point it just completely stopped working, right? So I got it back, took a look at it, and indeed it worked just like it was described to me. As always, I heeded Jeff Ryan's advice, make sure that the ON/OFF selector is in the ON position, but that didn't make any difference. So basically opened it up and tried to look at what was going on. And what I saw was that what's shown in the upper right hand corner there is that we have this little power regulator chip, and there's a test point there that's labeled 5 volts. And when I measured the voltage on that particular test point, it was much less than a volt. It was a few hundred millivolts. Started to look at the chip and saw that, no, we had a regular 12 volts on the input pin, but on the output pin, there really wasn't any output. So it sure looks like we've got a problem with a power chip. And if you actually look at the circuit diagram, which KPC publishes very nicely, you'll see there's a MEC 2951 chip, which is basically a 5-volt regulator chip. It's got 8 pins on it, but that's to make you do fancy things. Mostly what we use it for is to drive it just like you would a regular 5-volt regulator. So that's the pinout on it. If you look at the internal circuit diagram, it's basically a type of linear regulator. And on my particular device, this was a surface mount. So I could buy the new chip from Mouser for $1.17 plus $10 shipping. But the point basically was it's going to be surface mount, so that's going to be a challenge to solder. So can't we just replace it with something else? And so that's exactly what I did. So the first thing I had handy was one of those RECOM 78 E5s, which is basically a high efficiency buck booster that takes 7 to 30 volts in and will put out 5 volts at 1 amp. And it's one of those converters that actually has a little oscillator and it runs somewhere in the 40 kilohertz or so range, has a transformer to then take the power either up or down depending on what your application is, and then just re-regulate it for 5 volts. It's really high efficiency because it runs at high frequency. It costs about $4, so that's not a big deal, but it's actually pin compatible with the 78 series linear regulators. So I plugged it in or soldered it into the circuit, as you can see in the picture, and everything came back alive. So that was clearly the fix to this particular problem. But then I got to thinking, that thing's got an oscillator in it, and it's creating all kinds of noise. Is that going to be a problem? It didn't seem to work any worse, because the tones that we're decoding with this device is only about 2,000 hertz. But still, to be a little bit more paranoid, I just replaced that with just a regular 78 L05 linear regulator. It's the classic regulator chip, and the voltage range is slightly lower. It's only 7 to 20 volts, but the KPC only draws about 10 milliamps. So even though you're basically changing heat or trading heat for that voltage decrease, it actually worked out just fine. So 50-cent part to then actually fix the device. And ever since that, it's been working just fine. So you can kind of see in the picture there, it's a little wonky how I had to actually solder it in the circuit there, but I've used big enough solder blobs that it's pretty solid and it all worked fine. Exactly. So, the long and the short of it was, it's a $200 device, and it's a really good device. And all it took was a 50% part to actually make it work again. But, without that part, it would have been a doorstop. Clearly, a little bit of troubleshooting skills is a good thing to have. If you've got your voltmeter, first thing to check always is, does the device have power? If it doesn't have power, it's probably not going to work very well. And fortunately or unfortunately, that was the problem that in this particular case. But sort of the thing that just sort of struck me about this whole exercise was, right now having open source hardware is sort of a big deal, right? Especially in the computer world. But if you really think about it, as hams, we've had open source hardware since the 40s or 50s, right? If you buy a radio, or if you used to buy a radio from Heathkit or even from Yaesu or Kenwood, they actually give you the circuit diagram for the radio as part of your, what you get. So we have the ability to get into there, make sure that we understand the circuits, and actually fix things when they break, which is kind of what being a ham is all about. I always tell my served agencies that, when you get a guy from Aries, you don't just have a radio operator, you have somebody that if something breaks can fix it, right? That's what we as hams really bring to the table when we go out and provide services to various agencies. Okay, that was my 10-minute spiel on fixing a KPC3. So any questions?